Now is the right time to introduce our first speaker, Darko Mesaros. Darko is a senior developer advocate based on Seattle, Washington. His goal is to share passion and technological well known how to engineers what to do, how to do, to engineers, to developers, to builders, technical enthusiasts across the world. And most of his focus is toward DevOps and management tools, where automation, pipelines, efficient developer tools is the name of the game. So click less and code more so you do not repeat yourself. Also, he collects a lot of old technologies and trying to make it do what it should not. So, like deploy AWS infrastructures through Commodore 64. So, Darko will talk about the topic missing the forest for the trees, the art of observability. Be sure to ask Darko your questions, and the best question will get the prize from Yolantis. Use Slido, type your message, and we will communicate it to Darko. So, Darko, you're welcome. Over to you.
Thank you, Sergey. Thank you, Sergey, so much. I always love being here. I always love presenting at this wonderful DevOps meetup. I think last time I've done it a couple of months ago, it was something to do with Minecraft and open source tools. But yeah, that was also very fun. So today I'm going to be talking about something else. First of all, thank you all for joining me. Slava Ukraini. And I really hope that we can push those 30,000 hryvnia up for the folks up in Dnipro. So let's kick it off slowly. I will encourage you to ask questions if you have. I can't see your questions in real time, but hopefully the questions will get to me. So awesome. I do have some slides. I know people don't like slides, but I will try my best to make them interesting. And I also have some demos. So we're going to be doing some demos as well. We have 45, 50 minutes. So we have plenty of time to discuss. So get those questions ready. Anything you want, anything you feel like you want to talk to me about. Let's make this a fun experience. So I would love the wonderful folks out here, Dennis or whoever is helping me out, to share my screen. I'm not sure if my screen is being shared right now, but you should be able to see something above my head next to me or whatever, wherever that is. So is that visible right now? Can you confirm that? Yes. Okay, it is right now. Thank you so much. Let me go on a slide back. I'm using a little old saying here, missing the forest for the trees. In Serbian, I also come from Serbia, by the way. In Serbian, we would say promašiš šumu od drveta. That means you do not see the entire, you're looking for the forest, but you don't see the trees, right? So you don't see the forest from the trees, basically, right? So sometimes, even if you're looking for something, you're focused too much on a single thing that you can't see the bigger picture. So I'm going to be talking to you about something relatively modern, something relatively being talked about recently, something called observability. Now, observability is a word that that's being thrown out there a lot, and I think even like spell checkers don't recognize it as an official word. But observability is something relatively new, but not so much, but that can help you, the wonderful developers, engineers, DevOps people, platform engineers, or whatever you call yourself, to lead a better life, so to say. So let's take a step back. Let's talk about monitoring. Now, monitoring is a thing you most likely know about. Whether you're a system administrator, a DevOps engineer, a platform engineer, a developer, or whoever, you have heard about monitoring. Monitoring is that thing that makes your phone go buzz if there's an issue, right? And the goal of monitoring is to kind of detect issues, notify you about them, help you investigate them, and fix the problem. Now, there's a problem in that. The reason I say there's a problem in that is that is very much reactive, right? So imagine you sitting at your wonderful job, and somewhere Friday evening you received a message on your phone, or pager duty goes off, or whatever, says there apparently is a memory issue on one of the Java servers you're running, right? That can be in the cloud, that can be on premises, whatever. You find it, you investigate it, you find where the issue is. It's on this specific server, you're running Java Tomcat on it, and there's a Java application running there, and memory usage is through the roof, and like, okay, this is a problem. Easy fix, restart the server. Okay? Does that solve the problem? For you at that moment, absolutely yes, right? You've solved this problem, you go home, it's Friday, you don't have to worry about a thing anymore. However, next Monday morning, you come back in, same thing happens again. You fix it, and it happens again. You start to see a pattern. Something's happening constantly, and you do not know why. You assume in your endless wisdom that it is a memory leak, because most likely it is. It's a Java application after all, right? So you know that it's a memory leak, and something with the application doesn't work. So you go back to the developers, you go back to the people who have built this application, and you ask them, hey, listen, there is a memory leak in your application. And they just look at you like with dead eyes and say like, okay, tell me more. And you have nothing to tell them. And you'll say like, oh well, every day it seems to have a memory leak and seems to do a bunch of stuff to our servers, but that doesn't solve the problem, right? You don't know more details about it. How do? You need to investigate more. You need to dig through log files. You need to look at metrics. You need to, I don't know, maybe do some testing, or load testing, run different versions, whatnot. What if there was a way that you can kind of proactively detect these things, find the issues, analyze them, collect them, gather them, create a report, and improve your application in the long run instead of just fixing a problem? Well, this is the goal of observability, right? The goal of observability is to observe, right? To have a look or have an eye on. I like to use monitor here, but it's more than monitor. But observe whatever you're having running on your system, right? Your applications, your networks, your underlying infrastructure. You observe it all, and you constantly keep on analyzing it, right? You keep on looking for patterns, looking for issues, looking for outliers, looking for something that's not like it should be, anomalies, right? You keep on doing that, and ultimately, as you go down the line, you improve it, you fix it. That is the goal of observability. You constantly keep on improving what you do, right? The rule of DevOps: you deploy, you test, you look, you iterate, you go back. This observability helps you in this, helps you keep on doing this as you go along. I'm going to take another step back and give you an example from my past. A long, long time ago, I used to be something they call a system administrator. And system administrator, I used to fix systems, maintain servers. I smelled of a data center. And we had a dashboard behind my head in my office that was running Nagios. Nagios was a monitoring system. And it was just all like green or red boxes, or maybe some yellow ones if something was wrong. And my job back then, given to me by my manager, was to fix all the red boxes and not have them anymore on the screen. And the monitoring system was just doing weird things. It was doing, oh well, you have high CPU utilization, you have high memory usage, the disk IO is low, whatever. And the way for me to fix those would be just immediately go and fix them. And that would be my check mark for the day. Couple of years went by, those things were never ultimately fixed. They were constantly just being fixed on the day, and then a couple of days later, it happens again. If I had full tools and if observability was a thing back then, I would have been able to analyze, why is this happening? Why does this server keep on having low disk IO? Why does this memory leak occur and all that fun stuff? And then maybe I can fix it in the long run and not having to worry about it every single Monday morning to have the little dashboard behind me all green. So I'm going to talk to you today about observability. Before that, You may be wondering, who is this bald gentleman and why is he yelling at you? To introduce myself fully, first of all, I'll thank Sergey for the wonderful introduction. Everything he said was correct. My name is Darko Mesaros. I used to be a system administrator. I used to do things on Linux, Windows, Solaris, AIX, HPUX, all of those weird things usually people don't use anymore. And then I became something they call a developer advocate these days. So my job is to talk to you, the wonderful developers, builders, engineers, DevOps engineers, platform engineers even, about your use of the cloud, of tools, of whatever, and be your voice within the company I work for. And that company happens to be AWS. I'm based in Seattle, Washington. Originally, I'm from Serbia, and I've just moved to the States. Well, just 11 months ago. It's relatively new. So let's move on from there to something more important. Metrics, logs, and traces. These are the three pillars of observability. Now, there's a bunch of smart people out there who will disagree with me that there's actually more pillars. There's actually 6 pillars, or the church of observability, as they call it. I'm not going to get into that. I'm going to talk about the basics. I'm going to talk about the core here. If you want to go and expand on that, search for Church of Observability. No, sorry, Church, Temple of Observability. That's it. I think it was written by Yuri Shkuro. So he did that. So check it out. Let's talk about the 3 pillars of observability. Kicking it off with metrics. Now, metrics are the thing I told you about. It is the memory usage. It is the CPU utilization. It is the disk I/O. These are basically numerical representations, the number you see on screen of data, performance, user interaction, whatever you want to do with. It's basically a number that represents something in your application, something in your workload over time. Again, very typical metrics are your network bandwidth usage, your CPU utilization, your disk I/O, but they can be much more. They can be, how many times have people done a single thing in your application? How many times have people decided not to continue with their shopping basket and just drop the shopping basket? That's a metric number. That's a thing you can put in a number, a percentage, a pie chart, right? So this is very useful. Metrics are amazing. Not necessarily for identifying an actual issue at hand sometimes, but it's more like identifying trends, right? If I look at a server and I see the memory usage is 95%, that may not be a problem. That may be just how it works. But if I look at my metrics over a longer period of time, and then those metrics are just all over the place, and like they keep on growing and growing and growing, my memory utilization keeps on increasing, and then I potentially compare with something else like CPU utilization or disk usage or number of users in database, and I see a correlation saying, okay, there is an issue because my memory usage is trending upwards. There must be an issue. So it helps me, kind of predict things potentially, right? Not identify an error immediately, but predict things. Moving on. The next pillar in this wonderful world of observability is the logs. Yes, the wonderful world of logs. I wish I could see you all, and I would like to see your hands saying how many of you have spent days, dare I say nights, going through logs, right? Logs are just, as the name says, they are immutable, time-stamped records of events. So they actually record or keep a record or put a thing on about something that happened, right? A user was created, a user logged in, a payment was processed, a service has started, a service has shut down. So they are wonderful things for anything you want to do with troubleshooting, right? Um, I mean, let's be honest. If you start working with an application and it doesn't work for some reason, the first thing you do is go check the logs, right? There must be something in the logs that may indicate something is wrong. From a random 50503 error or a random 500 error on your application to a service not starting to whatever, right? You will look into the logs. It is very much useful for uncovering some emergent and unpredictable behavior, something that's happening that you don't see a trend for, something that just all of a sudden doesn't work. They're just wonderful, right? And they're like, for example, I'll give you an example of the metrics, right? Your application memory usage is trending upwards, and that's fine. But all of a sudden, your application starts seeing errors. Your application just starts failing. You get 5xx errors, or your just application crashes and whatnot. Um, to figure out what that is, you need to have a look at logs, and the logs may say out of memory, or there's no way to commit more things, something like that. You can actually then correlate, like, oh yeah, there's an issue. I can see that my memory usage is way up, and I have errors in the log files that relate to memory issues. You mix the two, boom, you get the potential cause for the issue. So metrics and logs have been used for a long time, right? It is definitely the thing you use to identify problems with specific resources, memory, CPU utilization, even something to do with an application. You can potentially uh, get information from them. However, there's one problem with metrics and logs in this little bunch. That's why we need a third pillar. You are lacking contextual information. So memory usage, right? It keeps going up, and then my application fails. How do you know why is it going up? Why is there something happening? For example, why is your disk filling up? Maybe disk usage is going all through the roof. Why is disk usage being filled up? How can you know that? Is there an application call that's doing it? I don't know. I can't figure it out. I mean, unless you're really doing some verbose logging and every system call, every application call is being logged, you most likely don't know. So that's where the third pillar of observability, tracing, comes in, right? Now, traces are something that seemed very daunting at first, but it is something that ultimately ties it all together. Now, traces are basically a representation of a series of distributed events, so not even connected events, that basically boil down to an end-to-end request. So you get a user that goes on your website and clicks, um, you know, add a product in the shopping basket, or clicks, uh, you know, signs themselves up for a mailing list. As they do that, there is a specific workflow that happens in your application. This call is being made. This Lambda function is being invoked. This API call is triggered. Maybe a step function step is being executed. So all of those different things are part of this end-to-end request that are actually being traced through tracing, right? And they're actually extremely useful once you have these things set up, because you actually know if an issue happens somewhere, how to dig into it. What exactly happened? Is there a latency bit with something? For example, maybe your users are complaining that, you know what, your website is slow. Okay, my website contains 100 different elements: microservices, databases, caching services, step functions, shopping carts, whatever. How do I know what's the problem? Um, Without trial and error, it could be very complicated. Even with trial and error, it could be very complicated. So tracing can actually show you, for example, where is there a latency between a call on your application stack. So tracing can be extremely useful when it comes to that. Basically, you see the entire path a user request has made to do a thing. So gives you very clear, high level visibility with the ability to drill deeper down into what actually happened to figure stuff out. So these are the three pillars of observability, right? And they kind of all encompass and go into this wonderful little center triangle called observability tools, where you have plenty of options, right? When it comes to observability tools, I think there's a lot of them to choose from, right? And this is where you can pick and choose what is the thing you would like to use to have your application be observable, right? I hate the word observable. I think it's a bad word because it's not an actual word, but okay. So combining all of these three with some tooling gets you the ultimate outcome, gets you the ability to observe your application, your workload, what the help gives you the ability to analyze what's happening, and ultimately to improve it in the long run. So it is something that's absolutely critical, especially for large applications. And I know you will say, Darko, listen, I just have a single website. I have an application that just does a thing. I don't really need to do this. And you may be right. You maybe don't need to do this. But think about it. Think about the pillars of observability as you go down the line, as your application complexity increases, as it starts getting more complex to maintain, uh, update, improve, and most critically debug, right? If you have a complex application that has become complex, um, debugging it's difficult, right? And I'm sure a lot of your applications you work on are going to become complicated at one point. That's how it works. It starts simple and it grows into a complex thing, especially in the cloud, right? With thousands of microservices, Lambda functions, and whatnot. So try to get in early, at least the important things, and then you can expand it as you go along. Okay, let's actually have a look at something, right? I'm going to try to do some demos here. I'm going to just show you how this looks like on AWS, and I'm going to come back later on to show you how you can do these things even outside of AWS, right? Maybe not all of you are on the cloud. So where is it? Okay, let me show you an application. Here's an application where you can adopt cute little pets, right? Typical application. Everybody builds these things. So it's a small application that just has a bunch of pets. I can click on this wonderful little husky here, and I can add a credit card in my credit card details here. I can add, whatever number I want. Luckily, my one password doesn't show my numbers immediately, but I do this and that, and I say pay. There you go. I adopted a husky. I can go back and I will say, you know what? I want to adopt this puppy white thing. I will say, okay, that's fine. Pay. Beautiful. I've adopted a bunch of pets. I can actually search for pets. I do bunny. I want bunnies. I want black bunnies. Is there a black bunny? There doesn't seem to be a black bunny. If I do this, my application seems to be very, very slow for some reason. There we go. Bunnies. Okay, I can adopt a bunny. If I say take me home, okay, payment details, boom, pay. Awesome. So I've adopted a bunch of bunnies, a bunch of pets. Things have happened. Things have been happening on this website. Now, this website consists of a multiple of things. It has step functions. It has Postgres databases. It has NoSQL databases. It has Lambda functions. It has containers. It's running on Kubernetes. All of those complex things are part of it. So to kind of figure out if something went wrong, for example, I found an issue that was pretty slow. Maybe we can figure out what went wrong. So if you go to AWS, to your wonderful CloudWatch console, there's a thing you can actually check it out. I would always start with X-ray traces. Now, X-ray is a tool that does tracing, right? It's a tool that just is used for tracing for all of those end-to-end calls, and this application has that thing built in. So if I go into the service map, you will see that there's a bunch of things when it comes to this. This is my pet site, right? Oh, there you go. Let's increase this to like an hour thing. And if I go to my pet site, you will see all of these different calls being made to different services, right? So when users go on my pet site, you will see there's a step function. There's like some remote API being made, an SQSQ. There's a bunch more services. There's an ECS container running somewhere, which is actually triggering something remotely on Amazon.com. There's an API gateway thing. There's a database, and a lot of different elements of my application. Right? If I go to my step functions, you will see a bunch of Lambda functions doing a bunch of different things. Yeah. So let's dive into this a bit. Let's go look at view traces. This will show me all of the traces being basically all of the stuff that's happened on this website, right? And it says 0 traces received. It could be because we haven't done, or it hasn't received them yet. So let me try to expand this search for a longer time, because I did something last night on this one. It should pop up hopefully soon, because it does take a moment or so. Let's expand this to, can I do 12 hours? Is 12 hours enough? 24 hours. Boom, apply. Oh, wow, okay. Then I can't. Only 6 hours. There we go. All right. Can I do absolute time? Let me see. I can do stuff. What is today? Today is the 26th. Let's do yesterday. And end time is today. Okay. Let's do that. Apply. Oh, it doesn't work. Refresh. I just don't want you to wait for me all waiting for these things. Okay. So this is not going to happen right now, apparently. But if we give it a couple of seconds more, because I do believe these things should have came up here. So select a node. This is a node, and you see a bunch of the latency. You see the number of requests. There has been no issues, to be honest, like no faults. But come on, you should definitely show me some traces, because stuff has been happening on this website. Nothing yet, it seems. Okay. Oh, there we go. Here it is. There has been some stuff happening here on the website. So I'm going to actually go and search by pet type. So I can go here and look at all the bunnies that have been searched or done something with the bunnies. For example, there is 27 seconds ago, I guess, or something, there was something that has happened with a bunny. So if I click on this one, you will see there's a trace of somebody doing something with the bunny. You will see all of the actions, calls to the payment APIs. You will see that paying for adoption is a container, actually, and a bunch of different requests being made with the lengths of those requests being made. For example, call to payment API is actually just a call to an API. I will see that it is there's no resources, so it's just being basically made a remote post call being made, right? That's it. No annotations, nothing. I'm posting a message to SQS. You will see the SQS message being posted here to a specific queue. And there's a request ID. There are a bunch of stuff here that you can kind of have a look at. You have SNS being done, right? Step functions. What is the execution being run here? What is the operation? So you see all of those little details happening here. The DynamoDB reads and writes. This is an update item thing. So if there was an actual issue, for example, there was a 1 second wait time here, or read for a DynamoDB, 840 milliseconds for a read, right? You will see some of these things. And this is where you can actually drill down deeper into figuring out what is going on. Is there an actual issue? All of these segments were okay. If there was a failure, it would be a failure, and you can actually figure out what went wrong. There were actually no logs created for this specific trace, but if I go and find something else potentially, if I go, I don't know, let's go here and find something more fun. Is there some logs? There's no logs. But yeah, you see the whole thing happening here. You see the whole interaction with the user. So as I went through this specific trace, it went through the pet search, searched it in the DynamoDB table, and that's it, right? So it's scanned for services. Is there something that we can have a look here? The metadata, right? You see a bunch of stuff, how it actually done. Yeah. So you get much more details in your application. I'm not even going to get into all of the other things you can do, from like your login sites and whatnot. But just by having a service map on and having tracing enabled, you can more easily figure out what's going on in your application, right? You can get all of these details by instrumenting your application to do stuff like that. Okay, I'm going to go a step back for a second right now, because not all of you are using the cloud, potentially, or not all of you are using AWS. Not all of you care about CloudWatch or whatnot. Maybe you have an application on premises. Maybe you have something running at home, or maybe you have multiple different cloud vendors, applications, sources of information that wish to feed telemetry, wish to feed information, monitoring, logs, metrics, whatever, into a common pool. So this is where the OpenTelemetry standard comes in, right? So I mentioned the little tools triangle. This is where one of those tools is an open standard. Now, OpenTelemetry is a cloud native compute foundation project, the CNCF project, and it's just a wonderful little thing, right? It's basically a collection of tools, APIs, and SDKs. It helps you have this common observability framework basically for any place. I mean, it says cloud native software, but anything can use the same framework. It's an excellent way for you to kind of unify all of your um, um, observability attempts and efforts into a single place. And it is open, right? It is out there, and you can relatively easily use it. It supports a bunch of languages. It has different already pre-made implementation. It has automatic instrumentation and all those fun stuff. I'll show you that in a second as well. Simply, how does it work? Right, there is basically an agent you need to have within the application or close to the application or something like that. Basically, your application code keeps feeding that agent with data. Usually, it's automatically done. You don't have to do a lot of things. And that data is then basically being collected in a single place by a collector. And then that collector can export that data to something else, like your monitoring services, your Grafana's, your Prometheus, your CloudWatch, even whatever you want, it can do that for you. So this is kind of a very much high level overview of how does it work, right? You have your microservices or your applications, your cloud infrastructures, your Google Clouds, your Azure's, your AWS's, your Kubernetes, your whatever's, and all of those things are sending OTLP, basically OpenTelemetry. I think it's language protocol or something. I don't know the actual acronym, but basically sending messages in the OTLP format to OpenTelemetry collectors, right? It's a centralized place where you collect all of that data. And that data is traces, logs, metrics, all of those fun things. And then that thing goes somewhere else, right? Again, goes to your Prometheuses, goes to your Grafana's, goes to your CloudWatches, or whatever kind of a monitoring system you use that supports OpenTelemetry as a data source. So in essence, this gives you the ability to use any tools out there, right? Your X-rays, your honeycombs, your New Relics. You can use languages out there such as C++, Java, Python, Golang, .NET, Ruby, Node, Swift, JavaScript, and a whole lot of bunch of different things, right? So there's a whole list of supported languages you can use out there. If you want, you can even use like Elixir and some of those functional languages as well. So it kind of jumbles that up all in the same place. And I'm going to actually show you how this all works in a sec, but it's a wonderful way to kind of abstract things away. So let's have a look at some code. I'm going to do this again. All right. So what I have here, if I clear my screen, is I have an application here. So this is a simple Python Flask application. Nothing special, right? It's just a simple Flask application that just has a roll dice. This is a very typical example. What people use is it's one of these little applications. Oh, wait, can I do this? No, I can't. I need to do it like this. All right. It's one of those simple applications where you have a little thing where you refresh the page and it gives you a different number from 1 to 6. Super simple. Now, what I'm going to do with this application is I want to collect metrics from this application. What I've done here, I've installed the what is it called? I need to find the little link for it. I've installed the OpenTelemetry agent basically with it. It's basically I've installed the the automatic instrumentation bootstrapper, right? So you do a bunch of pip installs. Basically, you need to install the OpenTelemetry distro like this, right? That's what you do. And then one of the things you need to do, you need to basically run the following command to bootstrap this Python setup with OpenTelemetry. And if I close on this and I just run my application, basically by preempting it with OpenTelemetry, I can actually do stuff. So if I do this, boop, application is running. So what I've done here is OpenTelemetry Instrument. Let me actually zoom in this. I see that this is a bit tiny. 1 second. I want to make sure that you all can see this way better than you should. You see up here, there is a thing. Yes. Oh, wait. I'll do it again. Clear. Okay. OpenTelemetry Instrument, basically exporting traces to the console and exporting metrics to the console. And if I open up this URL, which is basically this thing here, and I refresh it a couple of times, you will see, of course, logs come on screen, but also something else comes on screen. If I keep on refreshing this, you will see a bunch of stuff happening here. And you will see like information from like who is requesting this, context, like this is a trace. That's a trace for you all. Um, um, all of this data is being collected. And I can, in essence, get a full-on trace of what's happening to my application. And mind you, I did not have to do anything to my application. My application is just a simple Python application. There's no any of the OpenTelemetry thing here. It's just a Python application. So if I exit here, and at the end, you can actually see metrics, right? Now, metrics don't show up immediately. Metrics actually come a bit later on. It just, you need to collect a bunch of them for them to make any sense. So you will see a bunch of metrics here, like some times, duration of inbound requests. So this all looks much nicer if it was printed out as nicer JSON, but you will see metrics in a second as well. Now let's upgrade this. So I'm gonna actually move this app to start app. I want to save it. Let's do this pi, and then I'm gonna move the which one do I want to do now? I want to do. I have one here. 1 second. Is it the trace? Yes. Trace to app.py. Now the this one is a bit different. So we're actually importing the tracing from the OpenTelemetry object here. The reason we're doing it is because we actually want to do something more specific with traces. The traces you've seen before is just a trace, right? Oh, it has been executed. Here's some of the typical log information. That's it. If we want to do more, if we want to get more information out of this, we can add basically information to that trace. So what we're doing here is basically we're setting an attribute called role.value to this result, right? We're actually giving this number that comes out on screen, we're putting that into a trace. So we can actually do more with it. We can actually see what number did the user get, what pet did the user choose, what color did they try to search. So we're actually adding information into that trace, so it's going to be later easier to find. So what I do here now is I basically do the same thing. Run the OpenTelemetry instrument thing. There's nothing different to it. It's just the same thing, running traces and this, boom. Okay, same thing. Let's have a look. Refresh, to 1, 3, 5, 4, 2, 3, whatever. Bunch of different roll dices, and you will start seeing traces happening on screen. If I move this to the side and I go and search through the traces a bit, you will see the following thing. There is an attribute being set. Role value is all of a sudden a part of a trace. This means we have more information in that trace of what actually happened. It's not just a person refreshed or went through the slash roll dice page. They actually did something. So we've added more information into this wonderful execution. So you can get more information from that. Brilliant. Okay, let's go a step further. Let's do something more. Let's do metrics. So I'm gonna mv app.traces.app, and then I'm gonna mv metrics to app. Okay, so let's look at this one. So this one is very similar to the previous one. So we have the traces, we have metrics now. That's a new thing, and we're actually creating some meters, right? We are creating meters, basically counting the number of roles by role value. So we want to introduce a metric to our application to say, like, you know what? I want to measure how many sixes people get or how many threes people get. Maybe I can find an anomaly because my application keeps doing a lot of things we should not be doing. So We've added those things basically very much similar to the past. We do have a role span and just a role counter add. That's it. So if I run the application again with the exact same approach, boom, like that, and I do a couple of roles, boom, 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 um, in a bit, you should start seeing metrics come out. So one of the things you're seeing right now are just pure traces, right? No metrics whatsoever. So once I would like quit out of this thing and look at the output, I would start getting metrics. Now metrics actually look like this. So this would be the whole thing, right? You will see resource metrics, and one of the things you will see here is that, of course, number of requests, fine, that's cool. Server duration, fine, that's a neat metric. But if we go further down, we should see role counters. You will see role value 3, number of times 2, role value 2, number of times 4, role value of 6, number of times 1. So you actually get the metrics on your application data. This could come from the same thing. You want to maybe measure how many times people search for brown bunnies, and that could indicate that people would like more brown bunnies potentially, or that there, I don't know, some implication as you go forward with those things. Now, I need to step back for a second here. Nobody does things like this, right? I mean, you've seen data on my screen, you've seen some data in Vim, but is that useful? No. So what usually happens is that you actually do more. You set up something called an OpenTelemetry collector. Now, but it's a thing where you basically tell OpenTelemetry to, instead of outputting stuff on the screen, to output somewhere else. So I'm going to run a little Docker thing here. So if I go here and run this command, it's going to run Docker locally. It's basically going to run the OpenTelemetry collector locally on my machine. And now if I go back here and I just run even simpler, I need to install this, by the way. I need to install OpenTelemetry Exporter, basically, so my application can export OpenTelemetry data as OTLP. And then I just run this command here, which I'm going to the screen. And my application is now running, I believe. If not, I'm going to do 127.0.0.0.0.0.0.1 5000. Come on. That it's roll dice. Dice, roll dice. Yes. So if I bring it up here and I just zoom in a lot, refreshing the page, you will see a bunch of, just get requests here. However, you don't see any traces, you don't see any metrics coming up on screen. If I switch back to number 3, boom, things are on screen. And this is the OTel information the OpenTelemetry collector gets. Why would you use a collector? Because you may have a lot of different things piping things into this application. Now, what do you do later on? Again, Grafana's, Prometheus, honeycombs, whatever you want with this data, display it on a dashboard, put it in a monitoring system, and it works. All right, let me go back to PowerPoint. There's a bunch of different tools to solve your problem, right? From OpenTelemetry tools to Geoggers, to Grafana's, to OpenSearch, all of these kind of tools can help you to achieve really good observability. If you want more information, there's something more, there's additional resources. Here's a bunch of links. I would be happy to share these things via chat somehow if I can. But basically, check out the OpenTelemetry instrumentation, the OpenTelemetry registry, where you can find different entry. You can find actually the example with the pets I showed you. There is a workshop available to, basically, if you search for observability, AWS observability workshop, it's going to bring you there and can help you launch this entire pet website and all of the things there, and you can kind of check things out a bit more. And I see my face is frozen. So it's getting there. Hello. Okay. I see that. With that being said, before I say thank you, I want to say a couple of things. OpenTelemetry observability in general is important for the things you do. You do not know what you do not know sometimes. So in the effort of enabling you to troubleshoot things better, in the effort to help you improve your application or workload, your product, implement observability practices. Not just you can figure out what application is using the most memory, but maybe you can figure out what users are doing on your application. Where is the longest delay? Is there something that you can potentially improve that you don't even know? There's a saying within AWS, it's called dogs not barking. This means sometimes if there's no problem being yelled about, dogs are not barking, you may think there's not a problem, but there could be a problem just because nobody's talking about it. So think about that. You need tools, you need the right tools in the right place with the right correlation to ultimately figure out. So do not miss the forest from the trees. You need to see the bigger pictures, and applying observability practices, no matter what cloud, no matter what technology, will definitely help you in the long run. With that, thank you, Yakuyu, so much. I'm open for any questions if we have time, because I talk too much.
Thank you, Darko, for such a great presentation. We have various questions from our visitors, and I will start from the first one with lots of likes. What is better, to use short feedback loop from your customers or to create sophisticated observability logic that helps preventing problems? So be reactive or proactive.
So, okay, short feedback loops from customers are wonderful for a couple of things. You may get things that you really don't know what are happening, right? A customer may tell you an edge case, an issue that most people do not. It's not even being caught by the metrics, so you may get that, right? However, the problem with short customer loops feedbacks is that it may be just anecdotal, right? A customer may have felt the problem, or it may have been a one-off, an intrinsic thing. So I think a combination of having customer input directly as much as you can, with the ability to verify that input by having metrics, logs, and traces, it will ultimately be way better. However, by using on observability tools and metrics and logs and traces without talking to your customers, trust with your customers. So make sure to listen to your customers as you can.
Okay, I got it. Thank you. Yeah. And we have a question with lots of likes, and I guess it will be the last one for today. We'll send a list of questions to you also. And the privacy policy. So privacy policy with open telemetry. Should we notify our users, and how do we deal with this regulation, like European Union GDPR and so on?
So I guess this relates to like sending data to an OpenTelemetry collector that could potentially be private data. So
Yep.
I mean, this boils down to an issue with just data collection in general. OpenTelemetry is nothing special in this case. You know, you are collecting data that makes sense. So to be honest, ideally you should not collect any sensitive information or user identifiable data within a trace. You may call a user session, you may get a user ID, but you will not get like a user email or something like that. You correlate that information down the line in some database, which you can potentially sanitize in the future if a request for deletion comes in, right? So instead of dumping user data, name, email, whatnot in a trace, just put the user ID number or some sort of an UUID you can use, and then correlate that data somewhere down the line in your monitoring or in your analysis toolkit. I hope I answered the question with that. I don't know of any potential privacy issues with OpenTelemetry beyond that. But wonderful question.
Okay. So we should take it into account. Okay, so
Yep.
I guess that's all for questions for now. And please select your favorite one.
The last one, I love it. I'm a huge fan. I'm a huge fan of privacy and managing data successfully. The reason I like this question is because it actually touches on two things. Of course, data privacy and what the data should you actually transmit. And the other thing is that what data should you actually collect? Always ask yourself, if you're putting something in a trace, if you're putting something in a log, does that help you? Or are you just putting it because it's there? Right. So try to transmit as little data as possible while getting the correct amount of data to do analysis and improvements and debugging. So very important. I like the last question.
Okay, got it. So then, Ivan Heads, please contact us by email in the chat, and
Yeah.
you'll receive a present from us. So thank you, Darko, very much for
Thank you,
presentation,
Sergey.
for answering the questions, and have a nice day. Thank you. Bye.
Bye.